Hey homies, what's up? It's me, T1. Welcome back to my channel. So recently I've noticed that, there's a bunch of views on my first video, and, I kind of thought that, well, I didn't think actually that, you know, nobody was actually ever gonna, watch my videos, but hey, here we are. And I want to say thanks. It kind of means a lot to me. 30 viewers isn't much, but to me it kind of is. So thank you for that. So today this video is gonna be something a lot different. See, I'm gonna start off a mini series called the physics troll, and the whole point of this is that we're gonna mess around with various formulas in physics. So yeah, that's kind of the whole point. Now, I know this is gonna be kind of boring to y'all since it's physics. Not many people are gonna like this, but it'll have to do. So trust me. Uh, so we've got this first part right here. This is all the various formulas we're gonna use. Ohm's law, specific resistance, thermal conductivity. You've got the Wiedemann-Franz law, which is the ratio between thermal conductivity and specific conductance, and that being equal to the Lorentz constant times absolute temperature. Then over here you have the time constant, both of them. You have T equal to RC, and you got T equal to L upon R. Next up you have Joule's law of heating, where P equals to I squared times R, or V squared upon R, or you can just simply write it as V times I. Now let's go to the next page. Now this is kind of where the the whole mess of a festival kind of happens. So here, forgive me. So over here you can clearly see that we're taking both the time constant formulas, RC and L upon R. That way we can get RC is equal to L divided by R. That way you have R squared equal to L upon C. That way R is equal to the square root of L upon C. Now we kind of have to take this into the resistivity formula. That way we can have this. So I chose the length L to be lowercase in order to not make this confusing at all, but I'm sure it already kind of is. I get it. Anyways, you've got the cross-sectional area divided by the length times the square root of inductance upon capacitance. Then if you want to find the reciprocal of specific resistance, you'll have specific conductance. Now here you'll get L upon A times the root of C upon inductance. Again, I'm gonna say some of their names out because I really don't want to make the symbols confusing. The math is already confusing, that's for sure. So then you take the Wiedemann formula. You get kappa by sigma equal to the Lorentz constant times absolute temperature T. Then if you put it in here, you're gonna get, if you put this and put it on the other side, you get this being multiplied by it. That way you'll get here you'll have thermal conductivity being equal to L upon A times C upon inductance times the Lorentz constant times absolute temperature. Now, this isn't kind of really where it is. If you take the actual formula of thermal conductivity, you'll get Q by T, that Q being heat, not charge. This you'll get L upon A times 1 by delta T. Now, this is the temperature difference. This is absolute temperature, not the same thing. So if we put this forth, we'll get Q being heat upon T times delta T, which is also equal to under root C by L times the Lorentz constant times absolute temperature. Now, I don't know why I even did that one in the first place. I don't think that was even related, but I just wanted to, show you something, that's all. Now, this is going to be a kind of a different story altogether. Now you've got Joule's law of heating, which is power equal to voltage times electric current. Put resistance on both sides and multiply them. You'll get PR equal to VIR. All three of them at the same time, not bad. Now, this is where things get crazy. Suppose you were to, take this one in the form of specific resistance, and this one as, L by C. That way you'll get power times rho, which is specific resistance, times L upon A, which is equal to V times I into the square root of inductance upon capacitance. Now, again, things are getting even, more crazier here. This way you'll get P times length upon sigma, that is specific conductance, times A, the area cross section of the wire. That way you'll get here V times I, which times the square root of L by C. Now here see, P times L times Lorentz times kappa upon A. We kind of take this from the Wiedemann-Franz formula, that being equal to V times I times under root L by C. Yeah, I mean, this is gonna get as complicated as it's gonna get, but hey, it's worth a try. Then if we put all these variables on one side, we'll get P equal to V times I times sigma times A divided by L times the under root of inductance divided by capacitance. Or if you want to, take the thermal conductivity route, you'll get P equal to V times I times A whole divided by L times kappa, and this being multiplied by under root L divided by C. So yeah, I kinda, it's not really that interesting, but hey, it's some form of way that we can, mess around with the various formulas in physics. But uh, dear scientists, please don't, try to find me. I kind of, made this as a joke. But anyways, that's about it, homies. So I hope you enjoyed my little showcase. Uh, but I guess we're ending the video here. Anyways, please, like, subscribe, do all that stuff. And I'll be seeing you, homies. This is T1 logging out.